K. Nandakumar sir, who is a fellow senior scientist at the Energy and Resource Institute, New Delhi. He has done his post-graduation and PhD from Bharathar University, Coimbatore, India. He is an expertise in the area of environmental biotechnology with more than 14 years of research experience. His field of specialization in environmental biotechnology, bioenergy, bioremediation of wastewater and soil, emerging pollutants management. Currently designated as a fellow, before joining TERI, he worked in Sri Ram Institute for Industrial Research, Bangalore. The main research focus of Dr. K. Nandakumar includes the role of microorganisms in remediation of polluted environments, including total petroleum hydrocarbon, emerging micropollutants, development of specialized micro-electrochemical reactor system for the treatment of various wastewater and recovery of energy. Completed more than 15 research and consultancy projects. He is currently the principal investigator for the major research projects worth 1.5 crore for the oil drilling fluid product development. He has 25 international research publications and has presented his work in various national and international forums. He has also received various professional achievements throughout his career. Some of the notable are Young Scientist by Science and Engineering Research Board, SERB, New Delhi in 2014, Excellent Team Spirit Award in the year 2015, awarded International Research Credit Exchange Program, worked in Environmental Engineering Laboratory, Division of Civil and Environmental Engineering, Korea Maritime and Ocean University, Busan, South Korea for the period of 6 months, 2009. Awarded Senior Fellow SRF by Council of Scientific and Industrial Research CSIR in 2008. Awarded Bharathar University University Research Fellow in 2007 and the Best Environmentalist of Bharathar University in 2007. We are very much pleased to have with us Dr. K. Nandakumar sir. Now, may I request Dr. K. Nandakumar sir to kindly take over the session. Thank you, and over to you, sir.
Thank you, Professor Bikishta, and I really happy to be part of in this program, and thank you, Dr. Neog, for inviting me for this session and for the organizing committee and university management. So today presentation topic is waste management in upstream petroleum industry. I'm sharing my PPT now. Can you see my presentation now?
Yes, sir. It is visible.
Yeah. So very good morning to all, dear colleagues. Already, I think before going to the topic, I just like to brief about our institute, which is called the Energy and Resources Institute. This is one of the leading environmental research organization in India, which is headquarters in New Delhi, and we are working on various aspects of clean energy, water management, pollution, and energy research, including climate change. So this is our head office located in Lodi Road, New Delhi, and we have a regional office as well as TERI retreat in Gurugram and TERI University in New Delhi. And we have kind of different regional offices in Northeast and Bangalore, Mumbai, and Mukteshwar. So in our institute, there are different divisions, more than 18 different divisions working on various aspects of energy and environmental sustainable development research as well as projects. Mostly funded by Ministry of Science and Technology and other funding agency, as well as industrial consultancy projects. So, in which I belongs to environmental industrial biotechnology. This is mainly focusing on environmental pollution research and management projects. So, in my area, I'm working on bioremediation technology group. So we have two different research. I mean, one is activity based, that is mostly on field work, implementation of project outcomes through various collaborations, and we have TERI OTBL, that is called TERI ONGC Biotechnology Limited. So whatever the projects outcome, the research outcomes, it's converted into projects or product or process that is implemented through this joint venture company called TERI and OTBL, that is the TERI ONGC Biotechnology Limited, that is called OTBL. So the most of the research R&D projects which is taken care by Microbial Biotechnology Group. So some of the activities are like bioremediation of contaminated sites, pollution assessment, bioenergy, control of SRBs, then production of bioplastic, probiotics, including some of the clinical research in collaboration with various industries and institutes. So this is our facility which is located in Telegram. So we have a kind of different range of lab scale, pilot scale, and large scale biofermentation. So most of the products, which is a biological products, applied for the commercial application or pollution treatment. So all the products generated are produced in this facility. So we have 15 KL fermentation facility. Moreover, it is equal to industrial fermentation process. So wherein all the product is formulated and it is transported to the site for the treatment. So such kind of bioproducts also are developed here. So these are the fermentation facility center and laboratory we have. And my specific area of research interest is mainly already is mentioned during my intro. So microbial bioremediation is the primary research area. Apart from that, emerging pollutants also we are focusing, particularly microplastic pollution and emerging micro pollutant like pharmaceutical compounds, and some of the projects are also dealing with bioenergy. So consultancy areas includes kind of pollution assessment, bioremediation area, and bioproduct for the petroleum sectors, and even other area also we are working for the development of various bioproducts for the commercial applications. So we have two categories. One is basic and applied research activities, and consultancy projects area, wherein all the project developed in the initial stage is upscaled and commercialized through different kind of joint ventures. So when we come to the today discussion, that is today title is waste management in upstream pollution industry. So why we have taken this topic is mostly we are working on the finding out the solution to control the pollution generated from oil industries. So our main focus is on bioremediation. Still, we want to cover kind of what are the different waste generated during the production, that is the exploration and production process. So that is my first part of my topic, I mean today presentation, which mainly covers what are the basic information about the exploration and production process, and what are the different type of waste generated from upstream, that is the exploration and production process. During that process, what are the different types possibly generating from the oil industries, and what are the how it is categorized, and what are the legal requirements to manage these waste, and best environmental management practice That is the procedure which is adopted by the industries under ISO accreditation process. So then what are the management practice and methods? That is a systematic approach, how each stage, how what are the waste is generating and how it is categorized and how it is characterized and categorized and managed. So this is my today presentation. I just covered today. And another type part of presentation that is scheduled later, that is the case study. So mainly I will focus this case study from our own experience of handling and managing the large scale demonstration of bioremediation product in field level. So this is a very unique project from Indian biotechnology, environmental biotechnology side. So that we will discuss later. So when come to oil industries, there is a different stages of exploration production process. This is very well known to you because you are from petroleum background. So that is the main thing is the upstream process. That is the oil and gas exploration and production process. It may be offshore and onshore. So during the exploration and field development, production and operation and decommissioning stages, there are different categories of waste is generated that we will be going to discuss. And midstream is the kind of transportation of produced oil and gas to the through pipeline to the storage tank and transported to the refinery process. Then downstream process is obviously this distribution, or before that it will be refined and purified, then it will be distributed. So I'm going to touch only about the upstream process. So what are the upstream process and what are the type of waste is generating from this. So during the upstream process, the first activity will be seismic survey. That is the part of exploration and production process, and drilling of exploration well, then operation and production, and decommissioning and restoration. So when oil and gas upstream sectors, hazardous waste management is very important. So whatever the industries, upstream oil and gas industries, that is categorized under A because of the large hazardous waste. Whatever the waste generated, mostly it is mixed with hazardous material like petroleum, hydrocarbon. So this is hazardous to the nature and the environment. So that categorized under A category of EIA 2006. So which required the prior environmental clearance before any drilling activities. So because of this requirement, so any project which is proposed for oil well drilling, so it required to undergo the EIA process, that is the environmental impact assessment. So in that environmental impact assessment, that expert committee will have a kind of a field visit. That is a systematic approach. So what are the possible impact, environmental and other impacts due to the proposed project, due to the proposed oil or gas exploration and or drilling process? What are the possible significant environmental impact caused due to the proposed project? So that EIA reports contain all the impact assessment and what are the mitigation, and so according to the severity of the impact, they will propose for the mitigation measures. So once it is all the measures taken care during the implementation of the project. So that also will have a kind of potential impact to the vegetation, flora and fauna. All the component of environmental component will be considered during the EIA assessment. So this is the kind of process which will minimize the impact to the environment. So this is very important step in environmental aspect. So then come to the need to adopt the sustainable management approach to protect the environment as well as meet the energy demand. So obviously we can't avoid the project which required for the energy demand to meet the energy demand. Simultaneously we have to think about the sustainable approach, how we can able to minimize or reduce the impact due to that project on environment, which have different components. So we have one kind of project which is funded by DBT. So again, here it is a kind of green, because if you know oil well drilling, lot of additives, chemical oil well drilling chemicals. They used to call kind of drilling mud chemicals. So naturally, many kind of more than 30, 40 different kind of chemicals generally added, mixed together and form a kind of mud mix. So that is injected during the oil well drilling. So if we think about the green development or sustainable alternative to that particular, because once you inject tons of such kind of chemical, that creates a kind of sludge. After exploration or drilling process, what it will happen, it will produce a lot of waste from the drilling wells. So to avoid the or minimize the impact of such chemicals, kind of R&D we can R&D or chemical product development, which is also even our team also working on Xanthan gum. So Xanthan gum or guar gum. Xanthan gum is a I'm just little bit deviating from the topic. It is relevant to that because I'm just want to share what are the possibilities of proposing or developing kind of new research areas in this aspect, waste to energy or new green chemicals or green technologies. So I just take few minutes to explain this. Again here, Xanthan gum is a kind of bacterial polysaccharide which is produced by Xanthomonas. So that have a kind of viscous fluid. The Xanthan gum is a kind of viscous fluid. Instead of chemical additives, along with, or we can reduce the chemical additives and we can replace the Xanthan gum or guar gum as a drilling fluid, alternative to chemical fluid. So our team also have kind of a very novel Xanthan gum producing bacteria. So what we did is we isolated from natural environment with Xanthan gum producing bacteria. We isolated from different sources and upscaled, and we just compared the activity of this Xanthan gum based additive along with the chemical additive. So that what is the activity of these chemical additives and performance of Xanthan gum additives has been compared, and it gave a very good results. So already lot of products, such kind of products coming out from many of the foreign countries, but indigenous development of this kind of product is very limited. So we want to go for the Xanthan gum production, which is a green chemical alternative to the chemical drilling fluid. So we can minimize the chemical drilling fluid usage so that we can increase the green chemical production, as well as it have a very good kind of performance on drilling well. So such kind of alternate product is very important in this point of time, because we have to reduce the impact of chemicals on the environment. So we have the opportunity in each stages of our process, daily process, or kind of this kind of oil and gas well drilling process. So we can think about how to replace it or minimize it. So either way, we can reduce the footprint of these chemical products on the environment. So simultaneously, we can save the environment as well as health of human being. So this is one kind of such an example. So we then after successful trial in the field lab level, then we upscaled. So it's very much appreciated from the Department of Biotechnology. So we got this project, a major funding project from DBT. So now we just upscaling this. We already upscaled, and we will be going to demonstrate in the oil well. So once it is successfully demonstrated, then it will be this kind of product again, it will be commercialized. So it is a practically we can go into a basic research into applied research aspect. So when I come back to this oil and gas industrial hazardous waste management. So this is the legal requirement when come to the first stage of project. Then we have to assess the what are the possible contaminant from the drilling activities, and what are the impact. So we have to assess the impact of these particular any waste which is generated from drilling activities, that is the upstream process. So what it will generally do to the environment is it will increase the soil salinity, because when oil well is drilled more than 1,500 feet, so that will increase the soil salinity, obviously, because a lot of produced water is generated. Then the surrounding environment soil lose the soil fertility, and it also, apart from salinity, other toxic material like hazardous radioactive material will come out, and kind of you know this hydrocarbons also mixed with uh, produced water, and it will create a kind of hazard to the environment. And also it will change the properties of soil, and it affect the ecological, obviously it will affect the ecological function of the soil and the environment, and again it will enter into the food chain, and it creates a lot of no environmental, even microbial diversity will alter. So each aspect of environmental health will be affected. So that is the main reason. So each activity need to be assessed systematically. Then you have to propose the alternative measures, mitigation measures to control the impact, negative impact due to the project, any drilling project. So after drilling of any kind of oil wells or gas wells, then we have to go for the adaptation of best management practice, waste management practice, which need to be address the avoid the production of waste. First we have to avoid the production of waste. Then if not possible or partially, we can reduce the production of waste. If there is no alternate, then we have to go for the waste management practice, which is eco-friendly, or kind of it have to have a kind of both economical feasibility as well as environmental friendly. So then meet the project target also. So without losing any project or activities or process, we have to plan the project to avoid or reduce the waste. Second thing is we have to propose or adopt the best management practice. Then avoid the financial and legal liabilities. So obviously when we adopt with kind of friendly management practice, or avoid the production of waste or minimize, then it will help to minimize the financial and legal liabilities. Then apply the reuse, reduce, and recycle policy. So obviously, when we go for the reduction or reduce the waste production or reuse, whatever the possible product which is generated from the industrial process, then we can reuse. Then that again reduce the environmental footprint, as well as it give kind of economical benefit. And recycle. So either you reuse or recycle, then it will get benefit for the project, and it also minimize the financial and legal liabilities. So how you will handle or dispose the or waste which is generated from the kind of upstream process. So best environmental management system requires a systematic approach. So in field development or production or abatement of phases, any or closure of project, we need to identify the waste. What are the possible waste generating from the drilling activities or transportation? That is the midstream process. Even midstream process also, there are different kind of waste which is during the handling or during the transportation or the pipeline. There are a lot of solid waste, that is a sludge tank waste. So many hazardous waste generated. So we have to identify first. We have to identify the waste possibly generating from the upstream and midstream process. Then you have to characterize it. So characterization is based on the severity of the hazard. How so it required kind of a laboratory analysis part of it. So we have to go for the characterize the waste, then inventorization. So according to the characterization, whether it is a hazardous waste or non-hazardous waste, so such kind of inventory we have to prepare it. Then minimization. So after inventory preparation, how we will minimize, how we can minimize the waste generation. Either we can alter the process or we can use the alternative product to minimize the waste generation. So one example I mentioned is Zandangam project. So such kind of decision making we have to do after identification of stream, waste stream. Then we have to characterize it. Then we have to make the inventory. Then we have to go for the minimization. After minimization, obviously we have to go for the disposal process. So how to dispose? What is the best available method to handle such kind of hazardous waste? Either we have to go for the physical method or combination of integrated method, or we can minimize through the recycling or kind of reuse process. Then if not possible, or alternatively we can finally we have to go for the disposal process, which is best available technology we have to use to handle safely and environment friendly disposal we have to adopt. Then handling and reporting. So there is a legal requirement for waste handling disposal, so that we have to adopt, and integrated plan. We have to make the integrated plan for whole identification, characterization, and inventory management, minimization, and disposal. So any kind of industry, this is the common EMS, environmental management system requirement for any kind of waste which is generated from the industrial process, which is again applicable to the oil well drilling and processing. Also in the upstream process, midstream and downstream which is applicable. These are all common steps need to be adopted. Then each category of solid waste generated from, this is the legal requirement. So as per the EMP record, we have to report to the authority like State Pollution Control Board and Central Pollution Control Board. Based on the requirement, we have to report what are the waste generated, what is the adopted method, what is the hazardous waste, non-hazardous, and what is hazardous waste, how it is handled. Either it is treated, and either it is hand over to the authorized third party to dispose it. So such kind of inventory we have to make, and we have to report as per the requirement. So this is already I have discussed. We have to make the inventory, characterize and segregate the waste, and try to reduce, reuse, and we have to recycle. So these three key steps need to be adopted to minimize and dispose. So these are the then based on this process we can take the decision whether it need to go for the recycle, or we can either possibly reduce the generation of the waste or reuse. Either we can able to reuse any example, any chemical container or oil waste which is again used for road spreading, or cleaned drill cutting for road bed material. So nowadays a lot of technology innovation has been made in various industrial processes, which again help in reusing of byproduct or waste product. So this is the best example, oil recovery. So because oil cost is very high, and say small and very small scale industries are facing demand, energy demand. So what happened? Many of the used tires, like kind of even oily sludge, that is again used for the recovery of oil. So which have some kind of 20-30% of oil in the sludge. So again, that is also used for the recycling or recovery of the oil. That recovered oil can be used in various applications. So such kind of approach is now very well adopted in many industries, so that any material or waste generated from such kind of industries need not to be wasted. So that is the main aim of this. So what are the regulatory requirements associated with oil and gas exploration? So we go for the, because the EMS, that is environmental management system, is always the integrated system wherein all the legal requirement as well as the individual process requirements, everything is integrated and managed systematically. So already we have discussed that all the systematic identification, integration, and characterization, inventory, and the minimization, disposal, which also require the systematic documentation in each stage, and management of this waste in systematic approach. So that is the way. Then during that process, this is again the primary requirement to adopt or follow the legal requirement of any industries. So then all these common regulatory requirement is applicable to such kind of major industries, oil well drilling and processing industries, which is starting with the air. So we have to assess the air pollution. What are the possible air pollutants are emitted from the during the process? That we have to assess it, and we have to go for the analysis. So systematic analysis we have to do. Then we have to propose for the mitigation and control measures. Then again water. So again water, that is the Water Prevention and Control Act 1974 with its rules, Environmental Production Act, EIA notification. That is again to get the clearance from MOEF is very important for the starting the project activities. Then Forest Conservation Act, again prevention of diversity of any forest land for non-forest purposes. So such kind of all these air, water, all the environmental component need to be taken care during the initialization and process of any activities. So hazardous waste management and transparency rules, that is again amended. That is a new rules which is came into force in the year 2016. This is a hazardous waste management and other hazardous and other waste management and transparency movement rules 2016. So this will ensure the safe handling, generation, processing, treatment, package and storage, transportation and use, reprocessing, collection, conversion, and offering for sale. So such any kind of waste which is generated, which is characterized as a hazardous waste, so that need to be handled as per the guidelines given by the hazardous waste management rules, which is notified 2016. So we have to ensure the safe handling of the waste, and already we have discussed how we have to make the inventory of it, and we have to categorize, and what are the waste minimization or management rules have to follow. And again each stage how we are processing the waste, and how treatment method is adopted, and each stage how package, storage and transportation of such hazardous waste is adopted. Like that we have to make a each step what is the process, then that will be recorded and communicated to the regulatory authorities. So when all the requirements, the legal requirements is adopted, so that we have discussed, and what are the legal requirement, what are the management system we have to adopt, so that are the legal requirement we have to adopt in such kind of any large scale industries. And then we come to the significant waste streams. What are the waste stream possibly generating from the oil well drilling and process, that is exploration and process. So drilling fluid, that is the drilling mud sludge. So this is the major sludge which is generated from the drilling oil wells. So again, drilling cutting, the drilling mud sludge, as I already mentioned, it has lot of combination of mixture of chemicals which is injected during the drilling of oil wells. So more than 4 to 5 tons of drilling fluid is used to, it depends on the depth of the oil well. So average 2 to 5 tons drilling muds used for the drilling of oil wells. Then next is drilling cuttings. Then produced sand also, it is produced sand also generated during the drilling of oil wells. Then completion and well workover fluids, then naturally occurring radioactive materials. So obviously naturally occurring radioactive materials like kind of different radioactive elements which is generated during this drilling as well as the transportation. They use the oil well pipes which is abundant or after transportation of oil from the drilling well to storage tanks. So these even midstream process also, this norm kind of material, radioactive material is generated, so which need to be scanned and disposed systematically. So then oily sludge, so which is already oily sludge, that is a residue from the oil well. Then oily water, that is a produced water. So again, during the production of oil well, the huge amount of produced water, which is also again contaminated with that's a mixture of, major part of it is water, then uh, very less quantity of oil also mixed with water. So again, that need to be either treated, decentralized kind of ETP also generally used to treat this oily water on site, because it's a huge quantity is generated, so we can't uh, dispose in the open environment. So which need again systematic treatment, then disposal. Then activated carbon filters and oily sludge from oil water separators. So whatever the oil generated from the oil well drilling, that need to be separated from the uh, water. So activated carbon filters, there are huge number of activated carbon filters are used in the process. So that again need either that we can reuse it, and after certain time we have to dispose systematically. Then metals, organic waste, which is again kind of uh, other waste which is generated. Then gray and black water, because there are other associated support system, that is a kind of domestic waste will be generated from the working community. So many other waste also will be generated, so that need specific approach or method to treat that. Then solvents, then waste electrical and electronic equipment, because during the oil well drilling and process, there are different waste, that is electrical and electronic equipment waste also generated. Then incineration residues, so during the incineration, that is the residue will be left over, that need to be treated or disposed properly. Then plastic and packaging and used batteries. So these are all different direct waste and indirect waste generated from the oil well drilling and during the upstream process. So after identification of different classes of waste, then we have to characterize this. So we have to characterize the waste based on the characteristic. That is, the hazardous waste generally characterized based on the ignitability, corrosivity, reactivity, or toxicity. So based on this characteristic, there is a US EPA method to characterize the waste generated from uh, oil well drilling activities, the upstream process, so that we can either after testing, then we can categorize it, whether it is a hazardous or non-hazardous. If any waste which shows these three characters, which comes under hazardous waste. So we have to then, according to the waste characterization, that solid waste or chemical additives are generally ranked in different categories based on the sources as well as the hazardness. So example, the environmental ranking, the based on the waste characteristic and sources, which is mainly tank and piping sludge or waxes, or these wastes are generally have the significant environmental uh, no hazardous. That is, it have kind of inorganic salt, heavy metals, organics, BOD, sulfide. So these actually we have to make a inventory based on the hazard nature of the component. Then what are the significant compound which is present in that particular category of product or chemicals. So then we have to categorize. Once we analyze the waste, then we can categorize this waste into different classes. Then we can rank them based on the activities or hazardness. So we have to rank them. Then according to that, then we can prepare the minimization and disposal method. So when come to the drilling mud additives, generally which contain lot of mixture of various chemicals, that is a raw material like barite, carboxymethyl cellulose, deformer, chrome free, lignosulfonate. So these are all examples. Just I want to emphasize what are the different chemicals. This is one example which product, that is the drilling mud. This is one of the major consumable, that is a chemical or drilling fluid used in drilling of oil wells. So which contain the combination of different additives which made into the drilling mud. So that again have different environmental consequences. So we can reduce this impact with using the alternative chemicals also here. So we have just gone through the process, what are the process involved in oil well drilling, and what are the different kind of waste, classes of waste, and how to categorize it, and how to how to categorize the waste, and how to analyze, and we have to analyze and categorize the waste. Then we have to decide whether any waste can be reused, or reduction of that waste can be made through process change. If not, some limited component can be reused. Then we have to think about the alternative method, effective best available method to dispose that waste which is generated from the upstream process. So one is the reinjection. So generally the produced water, because in each drilling well there are huge amount of produced water is generated, so that need to be treated, tested, then we can use for this reinjection, so that we can avoid the surface contamination. Then incineration. So some part of the waste cannot be reused, so that need to be, we can go for the alternative method, that is incineration. Then how downhole method, so where we can, again it's a kind of reinjection process only. So maybe in we can that is the kind of what to say, this is a kind of controlled disposal of waste. Then oil water separation technology. So again here, again nowadays lot of no, even electrobiochemical process, even we have worked with one South Korean company, wherein he just developed the process that is in the initial stage of R&D. So we use the kind of membrane system, that is the electrobiochemical based membrane system, to separate the uh, produced water and oil. So again, produced water contain lot of hydrocarbons that can need to be treated. So that again, such kind of environmental friendly technology can be adapted to uh, separate the water from the oil, and again based on the characteristic of produced water, because different uh, based on the geological nature of the location, then water quality and salinity and physicochemical characteristic of water will vary. So accordingly we can design the process, then we can find out the solution. So each stage we have kind of scope, like us researchers or academician, whoever. So we can find out the like generation of produced water that can be managed, and energy recovery from the oily sludge. That is also again another research gap, wherein we can propose or we can develop as a kind of technology to manage this waste. Then no wastewater and kind of oily sludge. So that need a lot of intervention to manage or reduce the treatment cost with proposing alternate method, alternate product like integrated nanotechnology process and bioremediation along with nanotechnology. Also nowadays, lot of combination of processes in use to reduce the production process cost, the treatment cost, as well as um, develop the sustainable system. So then again, so we have to think on that line, so that we will get a kind of new product for the commercial application. So again, that will help us to go into next level. So next is the advanced thermal treatment, that is a gasification or pyrolysis. So whatever the solid waste which is again generated from the settling tank or kind of storage tank, or during the transportation process, or temporary holding tanks. So that again go for the recovery. So oil recovery is another important process, where we can reduce the solid waste generation from this kind of upstream process. Then after separation, some part of residue will be left over, that need again a kind of gasification or pyrolysis process. So here pyrolysis again, there also you can use a kind of thermal desorption units. That is a kind of thermal treatment, where we can use the steam that again pass through the oil containing sludge or soil. So that again once passed, that is a kind of washing of this sludge material. Then you will get a one treated solid material that can be disposed anywhere, because that doesn't have any hazardous material. Then another pot will be sludge, I mean oil pot, that again can use it for recovery. So such kind of option is available. Then we can go for the direct thermal desorption. That is a kind of direct application of fire onto the sludge or soily material, which is contaminated material. So again, there you will get there is no secondary product will be produced, only direct thermal desorption, where directly heat is applied to burn the oil. This is the residual oil left over in this sludge. So again, you will get the solid material that can be disposed safely. So that doesn't have any hazardous material. Then disposal in salt caverns. So there again, unused land, whatever the systematic disposal of kind of waste can be possible. Then bioremediation and evaporation pit. Again, evaporation pit is another thing that you can reduce the volume. Then once after reduction, you need to go for the either secondary treatment. Then bioremediation is another area where I will discuss from the basic for bioremediation to all the aspect in another section. Then we discussed about the handling, that is handling of treatment option for the various waste generated from the oil well drilling. Then management of basic waste type, that is the norm waste. So that is a naturally occurring radioactive material. This is the scales, how it is actually formed, which is a scale kind of formation in pipes and vessels are most common norms. These which contain barium sulfate, that is a strontium sulfate. These are all the radioactive hazard. It need to be treated properly. So vary with the production area due to different geological. Again, as I mentioned previously, this depends on the geological characteristic of the reservoir that norm waste will be different. I mean, characteristic of non-miscible. So, enhanced natural occurring radioactive material leads to internal and external radiation hazards, then significant radiation dose to workers. So, this is a hazards to the exposing group, that is a working group. So, it need to be scanned properly before starting any activity. So, norm survey is one of part of main activity during any such kind of remediation or kind of treatment process. So another is a radium. Radium is also concentrated within the small amount of solid scale. So radium, this solid scale when this drilled material, that is oily material, when transported, the radium scale or common scales like barium sulfate, all which is precipitated or bound within the solid scale in the pipelines or kind of transporting medium. So that's why each time they used to scan the now material before starting any kind of work. So what are the possible, this is a brief details of how to handle and treatment option. This is an overview we discussed, and now what are the waste management method is adopted are used commonly in such kind of upstream oil well drilling process. So surface impoundment, that is the use of solidifiers or solidification of pit contents, that is the commercial slum cements or fly ash or lime dust to help immobilize the pollutant. So immobilization is a kind of one such process where there is no alternate method or there is no availability of, I mean, treatment process, or you can't treat that process to completely degrade or complete disposal. Then you have to go for the immobilization. So that is the so all the pollutant which is generated, which is immobilized, so it won't further released or degraded or reach to the ecosystem. So landfilling is the another option, wherein a secured landfilling is also done to control the movement of any pollutant. Then biodegradation, this is again kind of complete disposal method actually. When biodegradations happen, then mostly like hydrocarbons, that are the examples that we will study in detail. Then the pollutant is degraded into non-toxic form so that there won't be any hazards from such kind of pollutants. Then deep well injection, that is again disposal method, that is the older method, that is the old injected in older wells that require more maintenance. Again have to check for the movement of that pollutant, or even drilling oil well or such kind of produced water is when it is generated from the drilling process, that is generally injected in deep oil wells, that is older well, unproduced well, so that you can reduce the treatment cost. But we have to make sure that before injecting these kind of produced water, we have to go for the testing of that material. Then we have to, I mean, that is the characterization. It is again systematic approach. Then followed by this, then this wastewater or produced water is injected in the older wells, that is unproduced well. So, as I discussed, we as a part of this waste generation, our team also working on bioremediation projects, particularly oil, sludge, and waste. That is the soil contaminated waste. So I very much interested in discussing about these case studies, which we will have separate discussion. That is how oil lakes or waste is generated, and how this oily sludge or effluent or contaminated soil can be treated through different process. So just I am giving here the overview. That is, we have to, once we characterize the waste, so example, oily effluent or sludge or contaminated soil, which is generated from the process or during our accidental spill. So we have to characterize that first. Have to characterize it, then we have to make the inventory. What are the characteristics? Whether it is highly hazardous, and what are the component. Then have to go for the treatment option. Example, for the soil remediation, that is the any oil spill or any kind of oil contaminated oily sludge, we have to go for the characterization. Then we have to characterize that. We have to assess the what is the component of the waste and what is the efficiency of the treatment. So once it is made, the treatment option should be selected. Then example, TPH, that is the total petroleum hydrocarbon, is less than 2%. So what is the risk-based approach? So we have to, what is the risk due to that waste, which is in the range of 0 to 2%. So either we can go for the phytoremediation, or so that required a very limited time to treat and we can dispose, safe dispose. Or if we go for, if the contamination level is between 2 to 7%, then we have to go for the treatment. So this is, you can't reuse it or you can't avoid the treatment. So in that case, we have to adapt for the adapt for the suitable method, either physical method or biological method, depends on the range of pollutant and components of total petroleum hydrocarbons. So when it goes more than TPH level 7%, then we can think for the reuse or recycle or disposal method, because there is a limitation for the treating this material under bioremediation or thermal desorption or physical method, that is called physical method. Then we can go, we have to go for the reuse. So reuse is another option where total petroleum carbon contamination is high. So there we can recover the oil from the sludge. So if not possible, then we have to go for the landfilling, because some of the weathered material which cannot be treated or cannot be used for the recycling or recovery purpose, oil recovery. So such kind of material need to disposed in secure landfill site. So what are the physical method? As I already mentioned, that treatment technique, which is physical method, either thermal desorption. This is a unit in one of our project in Kuwait oil company. We used to treat that contaminated material, that is a contaminated oily sludge or oily waste soil, that is treated through thermal desorption unit. So their direct thermal desorption also classified into direct thermal desorption unit and indirect thermal desorption. So this direct thermal desorption, that fire, that is a fire is directly applied to the material. So all the waste containing oil is fired and all the hydrocarbon will be removed, and we can dispose, or this is a kind of it become an inert material after treatment, so that can be again mixed with fresh soil and it can be used for the general application. So when comes to the indirect thermal desorption, they are in kind of indirectly heat energy source is applied, and that is a steam. That steam is generated from another generated, and it is applied on the contaminated material, so that all the oil containing soil or a sludge, it is separated, and you will get the treated, that is free from oil, that what are the solid material, and oil will be separated in another side. That can be again, it either need, based on the quality, either it need to be treated or it can be disposed in secure landfills. So these are all the physical method of treatment of contaminated sludge or oily sludge from the oil well drilling or oil industries. So when it comes to the energy recovery, again, as we discussed before, when material, that is sludge or oily soil, contains more than maybe 10% or 20%, then it can be effectively recycled or recovered for the oil from that sludge. So there we can apply the oil recovery system, where kind of systematic approach or a kind of solvent system will be used to recover the oil from the oily sludge. This is again a complex process based on the nature of the oil contaminated soil, that treatment method can be adapted. So it needs a lot of R&D and no kind of approach, and the success rate is very limited because of the complex process. Then bioremediation approach. So this I will be discussing in next session. That is, I think my another section is planned for day to tomorrow. So we will be discussing about the basic, I mean fundamental of bioremediation process and how it is applied in large scale treatment system. Thank you.
You, sir, for
Yeah.
such a wonderful presentation.
Thank you, Professor.
Welcome, sir. Participants can unmute themselves if they have any questions on the topic. Okay. If there is no question, I would like to express my deep sense of appreciation and sincere thanks to Dr. K. Nantakumar for giving such an excellent coverage on the topic waste generation in upstream petroleum industry, and for explaining so well about different waste management practices and about requirement to follow the guidelines under category A of environmental impact assessment 2006 before carrying out any ENP operations in order to minimize the impact on environment and how to adopt to sustainable management approaches and the requirement of shifting to xanthan and guar based product as a and it should be done in a very noticeable way to replace the chemical dealing fluids, and about environmental impacts of contaminated site, how, because this is the major issue, because whatever waste that is dumped to the, ultimately it will reach the soil, and it will weigh down the this soil fertility, and ecological imbalance is created. And how we can carry out this adoption of waste management practices. And you have also shared your knowledge and information regarding the case studies with which you are associated with. We have been benefited greatly from your presentation, sir, and we're very grateful for that. Before ending this session, I would like to request you to be with us for a couple of moments, so that we can take a snapshot of this session with our resource person along with the participants. Participants are requested to turn on their videos for photo session. Technical team is requested to take this snapshot. Hmm? Okay, okay. Thank you all. I have seen one question in the chat box. That is, in wire remediation methods, the metabolite products generated by microbes can be more toxic than the oil waste. How can we manage this toxicity?
Yes, actually, this is generally not all the waste will generate a kind of metabolites which is more toxic than the parent compound. This depends on the waste. So, example, in hydrocarbon also, all the fraction can be degraded by the combination of bacteria, because each bacteria have its own kind of genetic makeup, so that can able to degrade the various fractions, so that you will get the end product is non-toxic. And even there are, even we use in our Alzheimer product, where combination of four bacteria that can be that won't produce any kind of toxicity. So before developing the product, you have to go for this systematically. You have to select the bacteria which can degrade each component of hydrocarbons. Then we have to make a kind of consortium that can be, again, either you can use directly or in combination with other treatment method, we can go for the application. So directly we can't going to use any kind of product that can produce a kind of secondary toxic metabolites. So before application, we have to go for the selection of specific bacteria or any kind of method, so that cannot in all the cases it won't produce any toxic end product.
Is there any more questions? Any questions, participants? Okay, so I'm very grateful to you, sir, that you have taken time out of your busy schedule to address this AICT Academy FDP technical session. Thank you once again for your time and support. We'll be waiting for your next session.
Yeah.
We'll be waiting for next session on Friday. Thank you, sir. Thank you.
Thank you. Thank you.